Hello, good afternoon, dear students. Welcome to another channel of our robotics series. I am really happy to see you all once again over here. So, this series is all about Master Arduino like a Pro, and today is day 2. So, welcome back to sisyaclass, this series of robotics session. Moving ahead, here we have a quick summarization of who I am. My name is Ahmed Sir. I am Masters of IT and have done B.Ed from Mumbai University. I am a coding and robotic expert and have taught over 1.2 lakh students all across the globe. Here I am in front of you to explain you the concepts of robotics so that you can start your journey in robotics and become a pro. Now, be it if you are a complete beginner or you have some level of experience, this series will help you to understand all the basic concepts of robotics and start your journey towards becoming a pro in robotics. Right? So, let's move ahead over here. Once again, welcome to sisyaclass. And here is a series of videos that we are gonna bring in front of you. As we said in the previous session yesterday, that we will have a 6-day long series of videos. Today is day 2 and the topic that we are going to cover is how to use voltage regulators with Arduino Uno for reliable circuits. Okay, so basically in the previous session we saw that how analog and digital signals actually work. In today's session we are going to see that how voltage regulators can be used to change the voltage input by the which is given by the analog signals. And with this we'll try to make a project where we'll control the brightness of an LED using voltage regulators. Alright, so this is our topic for today. The very first thing that we're going to do is interface with analog signals. We are going to learn more in detail about analog signals. Then we'll see that how potentiometer actually works, and then we'll finally create a project. In today's session our project will be making a fading LED. In previous session what we saw is that the LED will either be brightly glowing to its full potential or else it will not glow at all, right? In today's session what we are going to do is we are not going to just make the LED bright up, but we'll also make the brightness of it change and variable, and that all with the help of the potentiometer. Okay, so I believe that all of you are prepared. If you have any questions or any doubts, or if you want to tell me something, you can use the chat section to interact with me. Moving ahead. So coming back to our analog signal, and we have covered this in previous session as well. Analog signals are actually signals which come from the real world. It actually represents a real life energy form. It can be temperature, it can be voltage, it can be sound, it can be light intensity, right? And there are many other sources of energy also that can be sensed in the form of analog signals. Okay, basically what analog signals is, if you plot the values of analog signal, okay, you will see that it is not defined to a particular high and particular low values as it was in digital signals. When it comes to analog signal, the value of that point can be any point between maximum and minimum. In this case, if you see, this point can be considered as the maximum and this can be considered as the minimum. I'll just write it down over here. So we have max and we have min. Okay. Now between this max and min, the values can be anything. It can be a point value, it can be integer value also, a floating point or an integer. It can be anything, right? And that's how digital signal and analog signal are different from each other. Okay, if you plot the graph of analog signal, usually you will get a sine wave which looks something like this. However, in case when you sense the values coming from real life energy form, in that case it's not always necessary that you will get exactly perfect sine wave, because it can be irregular as well. Okay, the temperature fluctuation, the sound intensity fluctuation might vary, and when for example if you use an equalizer to see the sound, to visualize the sound of an input device, you'll always see that the graph sometimes goes up, sometimes goes down, right? So this is how analog signal will actually look if you try to sense a real life energy form. Okay, fine. So this is what we should know before starting with interfacing of analog signal about analog signals. Okay, now since we are programming using Arduino, we need to know few functions which will help us to understand that how Arduinos can be used to interface analog signal. Okay, now there are two actions that you can do actually. What are these two actions? Action number one, either you can sense the analog signals from an outer source. Okay, this is one. Action number two is that the Arduino board can give out some analog signal to some external component or device. Okay, so there are two things. One, taking it from the outer source. Second is giving it to something else in the outer source, right? So taking and giving, these are the two things. Now taking and giving in coding language or in coding term will be considered as read and write. Okay, so read means to read something in the real world, write to send off the signals from the board to another component. Okay, so we have read and we have write. Let's try to understand this function in great detail. Okay, so we have analog read with a pin. Okay, here you will define that which pin number are you supposed to read the analog signals from. Okay, it can be A0, A1, A2, A3, A4, A5. If you remember, we had a total of 6 analog pins in our Arduino Uno board. Okay, so here we can write any pin numbers and take care of this thing that whenever you're writing the names or the names of a digital pin, you'll just write the number. It can be 1, 2, 3, 4, 5 all the way up to 13, right? However, when you are referencing to an analog pin, every number should be prefixed with the character A, which tells the code that we are referring to an analog pin and not a digital pin. So that's the difference between how you are referring an analog pin and a digital pin. Okay, now here if you see, here you will write the pin number. Let's suppose that I am writing over here A0. It means that I want to read the analog signals coming in A0. Okay, that's what it is mentioning over here. Reads the analog signal from the specified pin. Okay, I hope this is clear. Okay, doubts can be put in the chat section. Okay, now the next thing is analog write pin dot value. As I said, write. So write means giving off the signal to an external source. So which means that the signal will come out of the Arduino board and will go to somewhere else. Usually these signals are in the form of fluctuating voltages. Okay, now if you see here we have two parameters. One is pin and the other one is value. Okay, now what are these values? And we should know that what values we are supposed to pass, right? Okay, so pin will tell that from which pin am I supposed to, output this analog signal. This is one. Second, we have values. Okay, now value mean that what voltage value do you want to output from that pin. Now what can be the range of this voltage? For Arduino Uno, the range can be from 0 to 5 volt. The range of Arduino Uno analog pin is from 0 to 5 voltage. Okay, now we cannot write 0 to 5 in value, but we'll need to pass this value as a binary decimal converted number. Okay, which means that 0 can be referred to as 0, which is okay, but 5 volt can be referred as 1025, which means that when it comes to value over here, the value that you can pass is in the range of 0 to 125. Okay, so let me ask you one question. What if I want a power supply of only 2.5 volts? So what is the maximum? It is 5. So 2.5 is actually half of it. So which means that we'll go half of 1025, and that's how we can get it. That can be somewhere around 512. Right? So if I want to pass a voltage of 2.5 volt, so the number that I will pass in the value parameter will be how much? 512. And likewise, you can do certain calculations and find out exact value that you can pass in this parameter to give out the exact voltage that you want. Okay, so that's the difference between analog read and analog write. Read, if you see, read will do what? It will take the analog signal from an external source, and that will be considered as an input to the Arduino board. For analog write, the Arduino board will create the analog signal and will send it to some external component or to some external devices. Okay, I hope so this representation of how analog read and analog write actually work is really very clear to all of you, right? All right, okay, let's move ahead now. Now, the new component that we are going to learn in today's session is a potentiometer. Okay, a potentiometer is a device that helps to increase or decrease the resistance in the circuit. Now, with increase in circuit, the voltage will decrease. Okay, why? Because the resistance is actually the opposing force of flowing current. So if you are increasing the resistance, which means that the current will face more difficulty in flowing easily, and therefore voltage and current both will reduce drastically down. This can be very easily understood by Ohm's law that class 10 CBSE electricity chapter actually has, and that's how the science concept can be used in robotics over here as well. Okay, fine. So talking about a potentiometer, we have three terminals. Whenever we talk about any new component that are being introduced to us, understanding its working, its purpose, and the terminals that it has, these three things are really very important when you are talking about a new component. Okay, so this is a potentiometer and this is a wiper. Okay, this is basically a knob. You can rotate this knob, and you might have seen this many places, especially in your fan regulators. In your fan regulator, that is actually a potentiometer, which if you increase the speed, the resistance is being decreased so that more current can flow, and if more current is flowing, your fan turns rotating much more faster. If you are decreasing the fan speed, it means that you are increasing the resistance, which means that you are decreasing the flow of current, and therefore less current, so slower the fan will rotate. And that's how the speed of your fan is regulated by a potentiometer, which you call it as a regulator. Okay, fine. So this is basically the potentiometer, or you may say regulator, in our day-to-day life, that we can rotate this knob and then set how much voltage are we supposed to supply to the current. Okay, now there are three terminals over here: terminal 1, terminal 2. Now terminal 1, terminal 2 can actually be the power in, it can be power in, and then the other one can be power out. So let's say that if I have given a power of 5 volt, okay, I have supplied a voltage of 5 volt in this terminal 2, current of 5 volt will go, voltage of 5 volt will go inside it. Okay, and then this portion can be connected. See, power out, I've always mentioned, to complete the circuit, we will connect the negative terminal in the ground pin of the Arduino board, isn't it? Right? Now because this is the positive terminal, so this will eventually become what? It will become negative terminal. Now because if you see, the name of these two terminals are just terminal and it's not anode or cathode, it means that we can switch its places also, but we should understand the flow of current will be in what direction. So here we are supplying the current. If you are considering terminal 2 as power in, here is where we will get the current from. It will go through the entire regulator and it will come out from here. This is power out. So this will be connected in what? In ground. Okay. So what is the use of the third one? The third one is a wiper. Wiper means this knob, wherever it is set, accordingly the current will be passed. Okay. So let's say that this is 0 and this is full. So what will happen is, if you take your knob and keep it over here, no current will come from the wiper pin. No current will come from wiper pin. However, if you just rotate this to some extent, and let's say you are bringing it to the center, so center means half of the voltage will be passed. Now half of the voltage will be passed. If I am supplying a power in of 5 volt, how much volt will be coming from the wiper pin? We'll have 2.5 volts. And that's how, by rotating the knob, you are controlling the supply voltage in your devices. Okay, this can be used, this over here, this wiper can be used to connect to other component and then change the power, the power which is supplied to that component to make it dimmer or brighter. Okay, so with the action of rotation of this knob, we can control the voltage which comes over here. I hope so this is really very clear, and we'll do this practically so that you will get a better understanding about it. Okay, I hope you are all with me. Let's move ahead. Okay, so our objective will be use a potentiometer with Arduino Uno. Okay, first what we'll do is we'll just simply see that how we can use a potentiometer in Arduino Uno. And if you look over here, here is the connection. We have the Arduino Uno board over here with a potentiometer. We have terminal 1 and terminal 2 connected to the power pins. Okay, now if you see, this one is 5 volts, so it is getting a power supply of 5 volt, and the other end, terminal 2, is connected to the ground, which means the circuit is completed. And then we have the center pin which is connected to A0, and A0 will actually detect how much voltage it will get. Okay, now this voltage can be anywhere in the range of 0 to 5 volts, but the value that we will get is from 0 to 1024. It's converted into binary decimal number. Okay, I believe this is clear to all of you, right? Okay, so this is how the objective is. Once we understand how to make this project, we will modify it to some extent and then connect an LED and see that how this LED can, the brightness of this LED can be very varied based on the voltage that we are supplying in this component. Okay, I hope so this is clear to all of you. Yes, so now here is the activity time. We have understood today's concept. Now we can move to doing it in the practical way. Okay, so let me quickly go to our Tinkercad. We have used this in the previous session yesterday, right? So this is our Tinkercad platform, and if you remember, the way to create a new project is by going to this dashboard and then clicking on create and then click on circuits, and you will get a new project right away created for yourself. Okay, so it will take a moment to load. Once it is loaded, you can start with your programming. Okay, what I'll do is I'll take the Arduino board over here and then I'll take a potentiometer also. Okay, so here what I have done is I've used one Arduino Uno, and the second thing is the potentiometer. Now the potentiometer's terminals are facing not in the correct way, so what we are going to do is we're going to rotate it. Okay, so I'll select it and then rotate. Okay, till the time I get the correct orientation. Okay, so yeah, I am happy with this orientation, and now we can do the connection. Okay, as I've mentioned, the extreme left and extreme right terminals will be connected to the power source. Okay, so let's do that. Okay, so what I'm going to do is I'm going to select this and connect it to 5 volts, and then I'm going to select this and connect it to ground. Okay, now for my understanding and for my simplicity, what I'm going to do is I'll change the colors of the wire, and that's something that I personally really like to do, because once our project turns out to be very complex, it becomes really very easy for us to understand which wire is doing what. Okay, so ground, I always prefer ground to be black and the power to be red. Okay, then the third thing that we have over here is the wiper. Now wiper, where actually is my output voltage. So input voltage is 5 volt, output voltage can be varied based on how much you are rotating the knob, right? So I will connect a wire from my wiper terminal and then connect it to any of the analog pin. In my case, I have connected to A0. Okay, I hope so this is clear to all of you. Now I'll change this color just so that I know that which wire is doing what. Okay, red wire over here is the power supply, black wire over here is the ground, and then finally blue wire is the output voltage. Okay, I believe this is clear to all of you, right? Okay, now if you just click on start simulation, you will see that nothing special actually happens. Why? Because we have not provided any instructions. Okay, and these instructions can be given by coding, if you remember from yesterday. So we're going to learn some new coding stuff over here. First of all, we'll program as really good and professional programmers in text-based programming, and then we'll see that how all of these things can be done. Okay, what I'm going to do is I'll just remove all the text that we already have. We don't want any code over here. We'll start everything from 0. Okay, so void loop is empty, void setup is empty. Okay, all right. So as I've mentioned that every Arduino program should have two functions without which the Arduino program is not complete. These two functions is void loop and void setup. Void setup works first but only once. Void loop will run after setup, but it will run infinite times. Okay, so anything that we need to repeatedly do will go inside void loop, and anything that we need to do only once can go in void setup. Okay, so here I'm writing in void setup. I'll set the pin mode first, and the pin that we are going to use over here is A0. So I'm going to say pin mode, and see, this is C++ and it's case sensitive language, so you need to make sure that small letters are written in small, capital are written in capital, or else you'll land up in an error. Okay, moving ahead, so we have brackets, and after brackets we'll have semicolon, and here we'll say what kind of pin mode, which pin are we talking about, and what kind of mode are we attaching to that pin. Okay, so here what I'm going to say is I'm going to say that pin number A0 should work as, so comma, should work as input. So I'll say input. Okay, so pin number A0 will act as input. I believe this is clear. Okay, then one more thing is I want to see the values coming in over here. Okay, so for that I'm going to use serial monitor. If you can see over here, serial monitor, this will actually give you the values that you are getting, right, that you are sensing. Now in order to use this, you need to tell the Arduino board that hey, I want this communication to happen. So for that I'll say serial.begin. Okay, so we'll say serial dot begin, and then again open close brackets with a semicolon. Okay, now in serial begin I'll need to tell that at what frequency, or basically it is actually baud rate, at what baud rate are we supposed to have the communication with. Okay, it's something that actually makes sense in a physical Arduino device, where the Arduino device will be communicating with the computer that it is connected with a certain baud rate. Baud rate means at frequency at which the communication is actually happening. Okay, but here since it is a simulator, it doesn't actually make sense because the Arduino is technically inside my PC, right? But any which ways we'll still write it. Okay, so I'm going to say that 9600 is the baud rate. This is the frequency at which the board and the computer will be communicating with each other. Okay, moving ahead to the next part. The next thing is that we want to sense the voltage coming in from the wiper. Okay, so what I'm going to do is I am going to first of all create a variable. Okay, so the variable I'll keep it as int. Okay, so we have int and we have value. Okay, or we'll just name it as val. Okay, so int value is equal to, where will we get this value from? We'll get this value coming from the A0 pin of my Arduino board, isn't it, right? So if we want to read that value, we're going to use analog read function. Okay, so I'm going to say analog read. Okay, analog read. Okay, and then here also we have to keep semicolons. Okay, now inside analog read, if you remember, we are supposed to put the pin number from where I'm going to get the data. In my case it is A0, so I'm going to write A0, so A and then 0. Okay, and then finally I just want to print this value so that I get to know that what value is this pin being sensed with. Okay, so for this I'm going to say serial dot print ln. Serial dot print line, ln stands for line. Okay, and then here again open close brackets followed by a semicolon, and then here I am supposed to add what value am I supposed to print. The value that I am getting from the pin A0 is actually stored inside a variable. The name of that variable is called as val. So we'll basically pass this value over here. So we have val added. Okay. Now I don't want this happen to repeatedly perform this task again and again in fraction of second. I want to give it a delay so that every few milliseconds this will repeat. Okay, so what I will do is I'll add a delay. Okay, delay, and then we have open close bracket followed by a semicolon. Inside delay I am supposed to write the amount of milliseconds that it should take a pause before repeating the loop once again. In this case I am gonna just write 500, which means it will wait for half a second, and then it will do the same thing again, which means that in 1 second it will check 2 times that what is the input voltage coming in A0. Okay, so if we go back to our code, and then if we are happy with our code, we can just click on start simulation and we'll see if we get any error or not. Okay, well, we don't get any error. That's a good news. If I go to code, I'll not see the values coming in. Why? Because we need to open the serial monitor. If I click on the serial monitor, here you have the value as 0, which means that now A0 is not sensing any current at all. Okay, now what I'll do is I'll just move this knob, and if I move this knob, you'll see that the voltage has increased. You see, we have increased the voltage. See again, and if we keep it full, if we keep it at max, you'll see that 1023 is the value that we are getting. 1023 is the max value, and I said 1024 because we are starting from 0, right? Isn't it? So that is also counted. Fine, and therefore that's the value that we are getting over here. I believe this is clear to all of you. Here we created a very simple program where we saw that how changing the voltage can be sensed by the analog signal. Now it's time to modify this code and make our LED bright, dimmer or brighter. Okay, fine. So let's move ahead to the second phase of it. Okay, so what I'm going to do is I'm going to remove this wire now. Okay, and I know that this wiper is working fine, isn't it? Right? So I am going to add one LED over here. Okay, let's rotate it so that it's in the correct orientation. Okay, fine. And if you remember guys, that LED is a polarized component, which means that it has a proper or dedicated negative terminal and a dedicated positive terminal, and it should be connected in the correct terminal accordingly, right? So that we'll do the same thing over here also. This pin over here is actually the cathode. I'll basically flip it also once. Okay, so here we have the positive terminal. The wiper pin will be connected to the positive terminal of my LED, and if you see, this is the positive terminal. Okay, then the negative terminal will actually connect to ground. Okay, so this is how the flow of the current will be. Okay, see, first the current will go to it will come from the board from 5 volt and it will go inside the wiper. From the wiper, wherever the knob is, it will connect and go inside the wire and inside the LED. From the LED it will come back and it will go to ground. That's how the entire circuit will be completed. Okay, now if I start simulation once again, you will see that my LED has already broken up. Okay, however, let me change the knob value. Okay, if I change the knob value, you see that now the LED is still working, and if I reduce it, it has reduced drastically. I can do one thing more. What I can do is, if I click on this potentiometer, here I can set that how much resistance this potentiometer actually implies. Okay, what I'm going to do is I am going to put the value as 450, and we have did this calculation in previous session. Okay, so if we go to over here, we have 450, but not kilo ohm, we'll keep it as ohm. Okay, and then if I click on start simulation once again, okay, and if I move it, you will see that how the LED is actually very nicely changing based on the knob value. Still, if you see that it is to some extent still burning, we can reduce that part also. So what I'll do is I will keep it a certain range. So here what I can do is I can change this value to let's say 600, and it's just an assumed value. Okay, so with 600 I'll see that my LED, the brightness of my LED can be varied using the voltage regulator, and that's how exactly your regulator, your fan regulator at your home, at your office, at your school work, right? It's basically changing the resistance in the circuit which controls the flow of current and voltages. Okay, and accordingly what will happen is your fan will slow down or speed up. Not just fan, but anything which has the ability to control its speed or its light intensity or temperature. All of these things work on the same thing, potentiometer. Even you will see the same thing in electric iron as well, where electric iron will have a knob and you can control how heated up the electric iron plate will be, right? So that again is where potentiometer is actually used. In day-to-day life we call potentiometer as voltage regulators. Okay, so well, that's it for today's session, guys. I believe that you have enjoyed a lot, and I want all of you to practice. If you have any questions or any doubts, feel free to put it in the chat section. We at sisyaclass are always there to help you, and will be there to guide you and support you. All right, moving ahead to the next part. All right, so here is a quiz time for all of you. Okay, this is a time where we will see that if you were focused completely or not. Okay, so question number 1 for all of you: what will this line of code do? Now here I have merged two lines that I have written separately in my code, and I have merged it together. Now let's see that if you are able to find the correct answer or not. I'll take a pause. You can pause this video and then read the question and tell me the correct answer. Well, the correct answer over here is A. If you see, this is print the voltage value from pin A0. Whatever value, the voltage value A0 is sensing, print that value using the serial monitor. So there are basically two lines of code that I have merged together. The first one was printing, which was actually a separate line. Sorry for this. Which was actually a separate line in my previous code. And then analog read A0 was a separate line. I have basically merged this together, and by doing this I am not in a requirement to create a new variable to store the variable and then display the value in the variable, right? So these two values have been merged together, and therefore the correct answer is option A. Moving ahead, this is your next question. What is the highest value for analog pin? If you are connecting to an analog pin with highest voltage, what value in numbers can you get? Take a pause and tell me the correct answer over here. Well, yes, absolutely correct. The correct answer is 1024. The number will be 021023. A total of 1024 values can be there. So these many steps 0 to 5 can be divided into. Okay, I believe this is clear to all of you. If you have enjoyed today's session, make sure that you join tomorrow's session also, where we will be working with a temperature alarm system. This will be a safety device system which will keep on testing that what is the temperature of the environment, and if the temperature of the environment passes a certain threshold value, the alarm will buzz. This can be a very important project that you can use in your home, in companies, in industries, in manufacturing units, and also in office, to alert the people if the temperature is significantly rising. So make sure that you join tomorrow's session so that you understand that how these things can be done. Also, make sure that you download the sisyaclass app so that you are always connected with us, and you look at other subjects that we have to teach with you. We at sisyaclass provide expert lectures from expert top educators from India's top universities, from IIT and NIIT. So you can take a screenshot of this screen and scan this QR code to get the link to the application. The application is available in both App Store and Google Play Store. Well, if you really loved our work and really loved the way that we provide our love to you by explaining all of these concepts which usually students feel hard, and we make it in very easy way, So make sure that you are liking the video, sharing it with your friends and families, and also subscribing to our channel so that you don't miss on important updates. Also, make sure that you hit on the bell icon so that all the important notification reach to you on time. Well, thank you so much for being there. I really love being with you, and I'll come back again tomorrow at 2 o'clock for another video. Thank you. Pradeep.